Okay, I wanted to look at this second review section where we have to look at the line, just review of linear equations in general. And first we'll start out with just one of the basic aspects is the slope. And the slope comes into play in calculus, as a rate of change. We talk about rates of change a lot in the first unit. So the slope is one of the easiest rates of change. Lines, linear equations, or a linear function, it actually has a constant rate of change. Your x value has the highest power of 1. And yeah, linear functions are important because they are definitely one of the most simple functions, and they have something called a slope. We will look at the slope later, or like the rate of change later. But the slope basically is a rate of change. It's a difference it's a change in your y values divided by a change in your x values. And some people maybe remember the formula from algebra, where you have y2 minus y1 over x2 minus x1. That formula definitely will still work, and we'll show you how to put that into play in this example below. There's a new formula for it, kind of the same way for if you have a function. So this first little part right here, if you look at the f of x2 right there, it's basically like what is the output when you put x2 in. So remember, x2, that's going to be kind of your input, and then this f of x2, that would be your output or your y value from your function. So if you actually have a function given, you can plug in your x and get whatever the y is that'll go kind of on the top. So just keep that in mind. It may look weird in that format, but it's the same idea basically. Inputs on the bottom, outputs will be on the top. Okay, so let's take these 2 points right here and find the slope between these 2 points. What I would do, if you're using the old formula, you can just name these x1, y1, x2, y2, and it actually don't matter. You can name the first one the 2's and the second one the 1's. It actually don't matter which order. But basically we're going to find the slope here, the rate of change between those 2 points. So I'm going to take my 2's, let's see, 4 minus 3 divided by 2 minus 4. Just remember, it's your y's on top, y's overrun, and we'll end up getting 1 over negative 2, or negative 1/2 if you just want to write it in a simple way. So that'll be your slope there. Rise 1, run negative 2, if you want to talk about rise and run. That's the slope for those 2. Okay. And this example is kind of the exact same way right here. I'm doing another problem where you have the slope here. So you'll take your y's first, 3 minus 3, and then your y's, or your x's, will be on the bottom. x4 minus negative 1. So just be careful when you have like negatives. I always put them in parentheses whenever I subtract them. But you'll get 0 over, that'll be 4 plus 1 really. So if you like change the negatives to pluses, it'll be 5. Which 0 divided by 5 will just be 0. So that one, I guess it don't matter what you get on the bottom really. It ends up being 0, but that's how you'll do that. And then going from here, we want to actually be able to crank out the equations for linear functions. So we're going to go through a few examples obtaining the equation of a line. The main thing to remember here is that all you need is 1 point on the line, okay, or a point on the line, just 1 point on the line, and the slope. So all you need is just 1 point that's on the line and the slope, and you'll be able to get the equation of your line. Okay, you just need 1 point on the line. Let me put 1 here. Okay, so 1 point on your line and the slope, and that'll give you the equation. You can use either one of these formulas kind of to do that. At y equals mx plus b, you can use that. Your b is your y-intercept, so it's where your graph hits the y-axis. This is really useful if you are given the y-intercept. Like this first example right here, we have, like this point right here is the y-intercept. So it's very useful to use that first formula, that top slope-intercept form, because if you know the slope, the y-intercept, and you know the slope, y equals the mx plus b, right? It's this we're using. We'll fill in 1/2 for your slope. And then the b will be the 5. It's the 5, the y part of the point. But there's your 5, and that's your equation right there. So it's really easy to use that formula if you're given the y-intercept. Now, you may want to use the point slope formula, the bottom formula, if you have something that's not a y-intercept. So let's say you had another point here. We want to pass through 0, 5, and we'll say 1, 3 or something. So there's 2 points it goes through. Okay. So let's say you have you want to find the equation of a line where you have 2 points given, but you don't have the slope. Well, what you want to first do is first find your slope. So get your slope first. Now we want to say, okay, what's the equation going to be? Well, notice that we have 0, 5 right here. So 0, 5. Let me highlight this right here just real quick. 0, 5 is a y-intercept. So we already have the y-intercept for our line. So basically what I'm going to do is do that form, y equals mx plus b. And I'm going to say y equals negative 2x plus 5. And that'll be your equation. Okay. Now you could also use the other formula, the y minus y1 equals m and then x minus x1. You could also use that as well. Now I would still use that same 0.05 because there's a 0, but your y1 for this, remember how this was like x1 and y1 right there? I would use those points. You'll plug in where the y1 is, your 5, and then your negative 2 will go where the m is, and then it'll be x minus 0. You don't put anything for the y and the x, by the way, the one that's just a regular y and an x, because in a linear equation you always have like you have your input and your output. You have your x and your y, so you have to have those variables that stay there, and you just leave those alone. Now let me show you what this kind of ends up being once you simplify it a little bit. Negative 2 times x minus 0 is just x. So negative 2 times x would just be negative 2x. Okay? And then to get it to look like the formula there, just add 5 to both sides. So move your 5 over right quick, and you'll end up getting y on the left, and then negative 2x plus 5 on the right. See? They end up being the same. And furthermore, by the way, we use the 0.05 with that second method. You could use the 0.13 as well. Okay? And you'll end up getting the exact same line. So it doesn't matter which point you plug in to these spots right, the spots right here, the x1 and the y1. Like you can use either point in those spots right there. You can use 0, 5 or 1, 3, and you'll end up getting the exact same line. So you just got to remember you got to use one point on the line, one point that's somewhere in your line. Okay. Next, going down here, parallel lines. Parallel lines have the same slope, so maybe definitely a thing you want to make sure you note. Parallel lines have the same slope. Okay. Now, this problem wants you to find the equation of a line that's parallel to that one right there, the 3x plus 4y equals 19. And we want the line itself, when we make it, to pass through negative 8, 6. So we already have a point. So for the point slope formula, remember that's that y minus y1 equals mx minus x1. Okay. Point slope, you only need a point and a slope. Well, we have the point, negative 8, 6. We want it to pass through negative 8, 6. But we want it to be parallel to that other line. So all we need is a slope. What you're going to do is find the slope from this line right here first, and then use that slope in point slope with the negative 8, 6 to find the final answer. Okay. So we're going to first get this 3x plus 4y equals 19. Get into the y equals mx plus b form. And what we really ultimately want, the reason we're doing that, is so that we can grab the m part of it. We don't even care about the b part. We just want the m, the slope part. Okay, so I want to take that equation right there and solve it for y basically. So we'll walk you through the steps here just to review some algebra, some basic algebra here. Okay, I first want to take my my 3x away from this side, so I'm just going to subtract 3x from both sides, like that right there. And generally on this right here, I put the x part in front of the 19. So I'm going to have 4y on the left. That's all that's left because this kind of cancels out. And then on the right side, negative 3x, I put that part first. And then the positive 19, put it behind. So you can't combine those. Those are unlike terms, so you'll leave it like that. Last, all you have to do is divide everything by 4. And I'm just going to put 4 under each thing. So you divide this whole right side by 4. If you split it up, though, you're dividing each one of those things by 4. And this is what you're going to end up having right here on the next line. Okay, you'll have a y on this side, negative 3/4 x, and then plus 19 over 4. Don't even worry about dividing that. You don't even care about that. The slope we want to use is this negative 3/4. So use this slope right here, the negative 3/4. And then I'm going to come over here to where I want to do my answer. My y minus y1 stuff. So I got y minus y1 is 6. So I want it to go through negative 8, 6. So 6 will be my y1 right there. Equals negative 3 over 4. X minus negative 8. So, by the way, that x minus negative 8 thing, the negative minus a negative will end up being positive, so you can actually just make that plus positive 8 if you want to. Let me rewrite that so it looks, so you can kind of see it better. But this is really what you'll have inside parentheses, x plus 8. Okay. Now, a lot of times on that's basically the line right there. Like that's all you want to do ultimately is get the equation of a line. A lot of times MyLabs Plus will have you write it into y equals mx plus b form. So if you are having to rearrange it a little bit, go ahead and distribute your 3/4 to each one of these. You can use a calculator for the negative 3/4 times 8 if you need to. So just use your calculator, use your technology if you need it. Okay. Negative 3/4 times x, so just be negative 3/4 x. So leave that the way it is. Okay. And then this will be negative 3/4 times 8. You should end up getting negative 6 when you do that. Right there. Oh, so this is going to be interesting in the end. What it reduces to is very interesting. I'm going to go ahead and move this 6 over. The one that's by the y. So, what do you end up getting as your answer? Y equals negative 3/4 x. That'll end up being 0, like plus 0. So there's the simplest form. So you can write it in either one of these ways. These are the same line. I will say the bottom one looks a lot cleaner though. But you can write it in either one of those ways. But yeah, MyLabs Plus will usually have you vary it up depending on what they want right there. Okay, and this right here is a little good review of linear equations, just to kind of get you in the mindset of how to generate equations of lines and use point slope again. You will be using this in Unit 1 later on, and Unit 2. So definitely keep it in mind as you're going through the homeworks and things. Okay, good luck.